Okay, we're going to still continue with bondings and names and formulas, and we're going to go a little bit deeper now, and I'm going to provide you the list, an incomplete list of common ions that you might encounter in the course of your studies. First of all, we talk about group 1, alkali metals. They always have a charge of +1+. Alkaline earth elements have a charge, always has a charge of +3. Then we talk about aluminum with a charge of 3+, and these are when they form ions, okay, when these elements form ions. On the other hand of the spectrum, on the other side of the periodic table, you have the group 7 halogens. They will receive an electron from somewhere else, and they become one negative charge. Oxygen and sulfur is a 2- charge. Nitrogen and phosphorus, got something in my hair, a 3- charge. Now we're going to go into something different. We're going to talk about elements that are in the valley of the periodic table, the transition elements. Now, transition elements usually have multiple valencies or multiple charges. That means the atom itself can either lose 1 electron, 2 electrons, 3 electrons, or more. All right? It really depends on the configuration, electron configuration that you will study at a higher level. All right. Transition elements. Some transition elements, on the other hand, only have one type of charge, one valency. All right. And for our curriculum, we have to know the zinc. Zinc will always form a zinc 2+ charge, all right, 2+ ion, all the time, every single time. And because it only has one valency, you write the name zinc, and nothing has changed. Silver will tend to lose 1 electron, and so its name will be silver. However, when you talk about ions that have multiple valencies, they can have multiple charges, you need to represent them in another manner. And here we go. Common ones that you will encounter will be copper plus. Copper plus has only one valency, right? So the name of it is called copper Roman numeral 1. This Roman numeral will indicate this Roman numeral, which is the oxidation state, a concept we'll talk about later, represents the charge. All right, so the charge here is 1 because it states here 1. Copper 2+, which has a 2+ charge, will have an oxidation state of 2, and so you will represent this, write this name as copper Roman numeral 2. Iron 2+ will be written as iron Roman numeral 2. Iron 3+ will be written as iron Roman numeral 3. Lead 2+ will be written as lead Roman numeral 3. And lead 4+ will be written as lead Roman numeral 4. Now, how does all these things come together? We will talk about that in future lessons. Now we're going to switch over and accelerate our learning a little bit more by talking about and introducing the concept of polyatomic ions. Polyatomic ions are simply ions that have many atoms in there. All right? Poly means many. Atomic, you know what that means? All right. So these polyatomic ions, you can actually draw the diagram of it, but drawing the diagram is beyond the scope of this curriculum. So you end up memorizing a whole bunch of it just to get yourself familiar with it. Not a very good concept, if you mind me, but there is a pedagogical need, blah, blah, blah. I'm not going to go to a tangent. Anyway, cations. The only cation for polyatomic ions are ammonium, NH4+. And that name is ammonium. You got to remember these ions now. And you also got to remember these charges the common ones, all right, and how to write them. And there'll be clues later on, and I'll teach you a little more, all right. Anions, there's a whole slew of them. There's hydroxides, nitrates, carbonates, hydrogen carbonate. I'm going to bring the list closer to you, all right. Sulfate, phosphate, chromate 6, dichromate 6, and manganate 7. Okay, so these are the list of the polyatomic ions. I forgot to mention that polyatomic ions are charged atoms or elements that are covalently bonded. That are covalently bonded, something that we'll talk about later. But they behave as single units of ions. All right, they behave as a single unit, and they behave like ions. They move as a single unit and behave like ions. There you go.